Hi all, welcome to the session on the basic concepts and fundamentals of Orkes Conductor. I'll share my screen. Can you see my screen? Hello, Sankita. Can you see my screen?
Yeah, your screen is visible.
Yeah, okay. Myself, I'm Riza Farheen, developer advocate at Orkes. Today in this session, we'll have a walkthrough on the fundamental concepts of Orkes Conductor and Playground, which is a free developer sandbox that you'll be utilizing for the hackathon sessions. Let's get started. What is Orkes Conductor? Orkes Conductor is an orchestration platform that simplifies microservices, workflows, and events. In yesterday's session, you might have got an overview of microservices and distributed applications. Today we'll get to know how you can create a workflow and what are the fundamentals that involves in building a workflow in Orkes Conductor. Conductor is language agnostic, which means that you can code your application in any language of your choice. We do support Java, Python, C Sharp, JavaScript, Golang, or Clojure. That's a quick introduction on what Orkes Conductor. And now let's look at the ways to get or install Conductor. There are different ways by which you can set up Conductor. The first one is to install and run locally using Docker. And we also provide a cloud version, which is the Orkes Cloud, which has got exclusive enterprise version for our customers. And also we do have a free platform called Orkes Playground, through which you can walk through the features, test, and get to know Conductor. For the hackathon, you will be utilizing the Orkes Playground. Now we can look at the fundamentals of Orkes Conductor. In yesterday's session, you might get to know that we built applications as workflows in Orkes Conductor. The fundamentals of the Orkes Conductor, these three things are the main concept in Orkes Conductor, which are the task, workers, and the workflow. Let's look at tasks. Tasks can be called as a basic building block of an application or the workflow in Orkes Conductor. The tasks are mainly divided into three sections. That is, it is three types. You can call system tasks, the operators, and the custom worker tasks. These system tasks are the pre-built tasks, which means that you'll be available within the conductor. That is for activities such as calling an endpoint or polling an HTTP endpoint, etc. And the operators are similar to the ordinary programming language constructs, such as the switch cases. If you want to handle, you can use operators. For looping conditions, you can use operators. And to run task in parallel, you can use fork join. The system task and operator will not require an external worker to be set up. The concept of worker would be explained in detail in the upcoming slides. And the third one is the worker task, which will be denoted as simple or the worker task in Orkes Conductor, which means that it requires a custom worker, but it is to be set up outside the Orkes environment. That is what do you mean by requiring an external worker. Now let's look at the different system tasks. Conductor has HTTP tasks, HTTP poll tasks, inline tasks, event tasks, business rule tasks, JSON JQ transform tasks, webhook tasks, and JDBC tasks. Apart from these system tasks, there are other system tasks which we are working on and would be available to our platform soon. Now let's go in detail about each of the tasks. The HTTP task is used to make calls to remote services that are exposed over HTTP or HTTPS. In this case, if you're using an HTTP task, you can provide the parameters as input to the workflow, and that is according to a requirement, you can provide the input parameters. We do have the documentation which details all the input parameters and the SDK method. So you can go through it to understand what each of the input parameters does. And the second type of system task is the HTTP poll task. Here it is similar to the HTTP task, but here we are providing a specified condition. That is, it is used to invoke HTTP endpoint until the specified condition matches. That is, in addition to the input parameters to the HTTP task, we can also provide a terminal condition which will be evaluated after this HTTP endpoint is invoked. That is, if this condition evaluates to true, what happens is your HTTP poll task would be completed. And if it is false, what happens is it would be a conductor will schedule the HTTP task to poll at another interval. And this polling interval and the polling timeout, etc., can also be configured as input parameters to the HTTP task. And the third type is an inline task, which is used to execute necessary logic at the workflow runtime using evaluators. So we do have the support for a evaluator, and you can also provide an expression to evaluate as the input parameter, and the task would evaluate it for you. And the next one is the event task. That is, Conductor has some supported eventing systems such as AWS SQS, Azure Service Bus, and Kafka. So this event task can be used to publish an event into Conductor supporting eventing system. Then we have the business rule task. Suppose you have a vast spreadsheet that you need to evaluate, which is having too many rows and columns. So what you can do is you can input this spreadsheet to using this business rule task, and this task would evaluate the spreadsheet for you. So it is now supported in three different formats, that is CSV, XLS, and XLSX. Then we have the JSON JQ transform task. So the JSON JQ transform task allows processing of the JSON data that is supplied to the what you'll say task using the JQ processing tools, and it would be converted into the required format. So the examples of using these will be demonstrated like by the end of the session and also in tomorrow's session. Then we have the webhook task. So you know what a webhook is. So it is basically an HTTP based callback function itself, but it facilitates the communication between two applications. That is here the conductor and the third party application. So it can be used to receive data from other third party application. And we have like ready to use integrations for these platforms, that is Slack, Stripe, Facebook, GitHub, Zendesk, PagerDuty, Twilio, SendGrid, as well as Twitter. Then we have the JDBC task. It is like used to execute or store information in databases like MySQL. So here, while inputting the parameters to the task, you can provide the connection parameters that is required to connect with a desired database. So that is a quick overview of what system tasks are. And then next we have the operators. So these are the set of operators that is supported right now in Orkes Conductor. So let's look at each cases. So switch task is used for creating the branching logic. So branching logic means it is like basically the representation of the if then else cases that is coming in common programming language. Then we have the do while, which is sequentially executing a list of tasks. So we can provide a condition, and until the condition is true, we can like sequentially execute the list of tasks that is included within the do while task. Then we have the fork join task. So fork join task can be used for running task in parallel. So it will be having two sections, that is a fork part and the join part. So fork part means depending on the number of tasks to be executed, you can add as many forks required. That is, if you need to run 1,000 tasks in parallel, then you can add 1,000 forks. So a join task would be added at the end of the fork join, which will join all the, that is, it will wait for all the fork tasks to complete, and it would join the output of these tasks together using the fork join. And then we have the dynamic fork, and dynamic fork is similar to the fork join task itself, but here the number of fork would be determined at the runtime. But in the case of fork join, you can already create the workflow with the required number of forks. But in this case, like depending on some business use cases, may require to what you will say to determine the number of forks only at the runtime. So depending on that, these two can be used. Then we have the join task. It is used to join the all the four tasks within the fork. So in the join task, you can provide the task reference name, and it would join all the mentioned tasks. Then we have the wait task, and the wait task is used when the workflow needs to be paused for an external signal to continue. So these external signal can be manual interventions, that is manual human intervention it can be. And you can pause it like until certain minutes, certain seconds, certain hours, certain days, or until certain periods. So suppose you want to pause a workflow using the wait task until December, then you can like December 25th, then you can provide the date and time. So the workflow would be paused until that, and after that it will continue. So next is the set variable task. It is like we can create a variable which can be reused within other tasks within the conductor at a later stage. Then we have the dynamic task. That is, we can register too many tasks in the Orkes conductor. So what this dynamic task does is that when the workflow is executed, we can dynamically execute the task. So it can be taken based on the input parameters, etc. Then start workflow means if you want to start another workflow from your current workflow, you can use this operator known as start workflow. For example, if you're running a subscription use case and you want to start the same instance if the customer renews, and if you want to stop it, you consider that case. So in that case, you can utilize start workflow to start the workflow again. And sub workflow means it is used for executing another workflow within the workflow. So the difference between the start workflow and sub workflow is that in sub workflow, there is a connection between your current workflow and the workflow that is included as a sub workflow. That is, only if the workflow that is added as a sub workflow is completed, your workflow would complete it. But on the other hand, for start workflow, there is no relation like that. That is, when the workflow reaches at that point, it starts a mentioned workflow. That's it. And then as I mentioned, if you want to stop your workflow, you can utilize this terminate task, and you can also provide a termination status and reason. And if you want to terminate another workflow based on the conditions evaluated in this workflow, you can provide the workflow id and terminate that workflow. So that's it regarding the operators. And the third type of task which I mentioned is a worker task. It's also denoted as simple task. So here it requires an external worker for polling tasks. So as I mentioned, for system task and operators, it will be executed by the conductor server itself. But whereas for a worker task, we'll require an external worker for polling the task. And this can be implemented in any language, and the conductor SDK provides certain features such as metrics, server communication, and polling threads for the worker task. So next we are going to the next most important factor, that is the workers. So workers are responsible for executing a task. So and these workers for simple tasks requires to be set up outside the Orcus environment. So what happens is the worker will poll for the conductor server to check if any work is scheduled. So if any work is scheduled, what happens is the conductor will pass a workflow input into the execution, and the worker will execute that task, and it will collect the output and it will send it back to the conductor. So we need something to link the worker and the conductor server. And for that, you can create applications within the conductor. So I'll show how to do this while in the playground after this, like towards the end. And these workers are supported in almost all languages. So this is an overview of what I've discussed right now. That is, tasks are of three types, that is operators, system task, and the custom worker task. So operators and system tasks are built-in tasks, which means that the conductor worker would execute them. And the custom task, you need to set up a worker outside the conductor environment. So that's it about the workers. Now next one is a workflow. So it is the combination of the tasks, that is a system task which we have mentioned right now, the worker task, the operators, the workers. So all these combine together to form the workflow, and this workflow is the application. So the applications are created as workflows, and the workflow is a combination of all these three things. So first step while creating an application is to create a workflow definition inside Orcus Conductor. So you can create workflows like as a combination of the operators and system tasks, like depending upon your use cases. So you can create simple application as well as complex application, which has like large number of building blocks. That is a large number of tasks. And Orcus Conductor has got some inbuilt features such as it will retry on failures, and it can time out after like specified seconds. And there is failure workflow. That is, if your main workflow fails, you will have to compensate the actions that is completed. So in order to complete that, we have an option called failure workflow. And also we provide a conductor UI through which you can visually debug and find out the um, issues to detect them easily and fix them. So the applications can be defined in different ways, that is using the UI. So we have a UI method through which you can add the required task and operators and build your workflow, or you can create the JSON code for your application and then you can create the workflow, or you can also use create them using codes like in different languages. So once a workflow is created, the next step is like executing or running the workflow. So this can be done in different ways. So in Orcus Conductor, you can execute a workflow using API call from Conductor UI, from a webhook, and we have discussed right now about the event task. So in response to an event coming from an eventing system, and there is some feature called workflow scheduler. So using API calls means we have the Swagger where the APIs are stored. So you can get the API to start the workflow, provide the input parameters, and then start the workflow using the API call. And from Conductor UI, there is an option to run the workflow by choosing the workflow and providing the input parameters. Then I've discussed about webhook. So when webhook event comes, the workflow would be started. So that's another method. And there is also when an event comes from the eventing system such as Kafka, the workflow would be started. And this workflow scheduler means you can schedule the workflow. For example, if you want to run a specific workflow at 10 a.m. every morning or every weekdays, you can create a schedule accordingly, and then so that it would be automated. For example, in the monthly subscription case, if you want to run a workflow like every month, like every 28 days, so you can create a workflow scheduler to run every 28 days, so that your workflow would run for every 28 days and your subscription process would be automated. So now let's look at Orcus Playground. So this is the one which we'll be utilizing for the hackathon. And so this is how the workflow playground looks like. So when you log in, you go into the execution page. So here is where we define the workflows, tasks, etc. So we'll look one by one options. So here is where you define the task. That is, for worker task, we need the task to be executed by the like worker setup outside. So here is where you define the task, and you can define the task by providing the parameters. So let's create a test task. So you can configure it according to your requirements. So for the demonstration, let me just quickly save this. Okay, so it is saved now. Now let's look at how to create a workflow. So click on define workflow. So at the beginning, you'll be having like this way. So let's start adding a workflow name. Okay, so I've created the value. We need to provide it as description too. So now let's start adding. So you can see the system tasks which I've discussed right now. You can see one by one it is listed. And the operators also you can see. And this is the third type of task which I have mentioned, the worker task or the simple task. So let me quickly create a task with HTTP. So if you click on the workflow, you can see task. So here is the task parameters. The task will have a task definition, that is the name, and that reference name for the task. So this should be unique. You cannot reuse the same task reference name. And these are the input parameters. So I need to get the details from this test URL. So you can configure this according to a requirement. And we have also linked the doc. So if you need any configuration and the description, you can get it quickly from the UI itself. So you can also provide versions to the workflow. So this is the JSON code of the workflow. And if you need to provide any input parameters to the workflow, you can provide it here. And you can configure the workflow timeout seconds, etc. And I've mentioned about a failure workflow. You can also add that. So Let's save this as version 1. Okay. So now let's run this workflow. So in order to run the workflow, this is the UI method. And let's provide the workflow, and it is having only version 1. So in addition, you can also provide the correlation ID. So this correlation ID can be used to filter the workflow executions, maybe like to relate the workflows. And there's an option called task to domain mapping. It is the concept of limiting your task execution to your specific domain. For example, if you didn't you are running a worker task, and if you're not providing a task to domain mapping, means there are chances that other workers can pick up your task and complete your workflow. So in order to avoid that, you can limit the workflow execution to your domain. So now let's run the workflow. So on clicking on this this is what is referred to as a workflow ID, so it would be generated. So clicking on it, it would take you to the workflow execution page. So you can see that the workflow is completed now. And if you click on that particular task, you can get the individual task summary, that is the task input, the task output details, etc. And if there is an option to restart the workflows or rerun the workflow or to create a schedule from here. So now let's edit this workflow and add two more tasks. So maybe let's add a wait task and let it wait for 5 seconds. And then let's add one more HTTP task and let's save it as version 2. Okay, so now this workflow is having different versions. So this is a version 1 with one task. So according to the requirement, you can have different versions of the same workflow. Now let's run the second version and let's see the execution. Sorry, it ran the same version, I guess. Not sure like what went wrong with the version. Okay, I think let's update it to the same version itself. Okay, so if we run the workflow now, you can see that it is waiting for 5 seconds. So after 5 seconds, let's refresh and see. So it's completed and then moves to the next step and it is completed. So if you check the task list, you can get the details of the individual task that is added in this workflow, the type, like when it started, when it ended, and what was the status. Then you can have a timeline view too, then a quick summary on your workflow and the input output parameters, etc. So this is how you run a workflow. Now there are certain other things such as scheduler. So this event handler I've mentioned about, like receiving events from Kafka, Azure, SQS, etc. So in that case, you can define it under event handler. And these are the schedulers. That is, you can define schedule. That is, you can provide a name for the scheduler. And this is where you define, for example, if you want to run a workflow like every hour, then you can choose this cron expression. So here it would show the time, that is it will show your local time too, that is it would be run at every hour. And you can choose a workflow here. Maybe we can choose a workflow which I've created right now, and the versions also you can choose, and in addition you can change the parameters, etc. here. And if you save this, so what happens is your workflow would be run at regular. I think there is an already a schedule with this name. So you got an error. So you can change it. And what happens is at every hour, your workflow would be run. So this can be automated. Example using the scheduler, which I'll explain after this. And then we have the secret. So you may have the secret, you may have the values or which need not be exposed to the workflow. So in that case, what you can do is you can create a secret. That is, you can provide a secret name and a secret value. So that is a secret to be used within the workflows. So what happens is it would get saved, and while creating workflows or while referring to this in workflow, you can use this secret name instead of the copying the secret directly. And you can also add tags to workflows, tasks, secrets, etc. That is, for example, if the secret is to be accessed by all the accounts team, then you can add a tag to just to identify it. So you can like these tags can be used to share permissions in bulk, etc. And then we have the webhook. So webhook, you can create a webhook. That is, you can provide a name and then the workflow you can choose. That is, on receiving the webhook, which version should run. So you can choose that, and you can we have like ready-made integrations for these platforms. So if you want to use any other platform, you can just choose a custom option and the add headers. So what happens is when the request comes, what happen this workflow would be initiated. So that is the thing with webhook. So there are different types of webhook, like the different ways, that is, if we create this, and let's say Slack, what happens is a URL would be generated, and this URL can be verified like by different ways, so depending upon the type of webhook. So we have a detailed documentation on this and the different steps to verify this. You can go through it to get an understanding. And then we have this section, so only the admins can view the section, like the users and all groups and all, only admins can create. So what if you want to invite a person, you can go to the users tab and provide the email ID, and then they can access the Orkes Conductor console. And if it is groups, let's create a group, maybe like test devrel, and let's provide a description and let it be users. So I've created a group right now, and you can assign roles in bulk. That is, if everyone needs to be the admin, you can provide that, and provide that. And you can add the members. So if you want to provide, for example, a particular workflow requires like permission to 1,000 members, you guess, then you can add all these to a group and create a group. And once you create the workflows, you can add the permissions here. That is, here you can add the workflows, tasks, secrets, tags, and domains here. So for example, if everyone requires access to this workflow, then you can add execute permission so that they'll have execute. So depending upon the requirement, you can choose a permission and then add, so that the you can like provide permissions in bulk. Similarly, you can also create applications. That is, I've mentioned that while setting up workers outside the conductor environment, we need to set up the connection between that worker and your Orkes Conductor console. So, in order to that, you need to create an application where you can generate an access key and secret, and using mapping the secret with your worker, that your worker instance will be having connection with the conductor server. And here also, similar to the groups, you can add permissions to the workflow, task, secrets, tags, or domains. So this is how you provide permissions. And then we have the executions page where you can view the executions. For example, this workflow which I've completed right now. And if you want to see the complete instance of the workflow, you can search for that. So this is a kind of reporting you can search. And then we have the same for scheduler, as well as this is a task queue monitor. For example, if we check, this particular wait task is having like three workers to be, you can see it like a minute ago, two requests is there, and like you can see the details from the task queue monitor page. So, and regarding the API docs, you can get the Swagger from here, and you need to authorize it and use it. So that was it regarding a quick walkthrough, and let me go through an example which we have created and using right now in Orkes. So our stand-up updates are like automated using this workflow. So here what we have utilized is a fork join task, which I've mentioned right now. And for a demonstration, we consider that we have only two forks, that is two employees. So each fork correspond to each employee, and we have added sub workflow because this is like a lengthier one, so we need not add it multiple times. So instead we'll create another workflow and call it as a sub workflow. So this is the employee one's update, this is the employee two's update. So you can see using an HTTP task, we'll get the Slack endpoint, and then what happens is we'll give a like using a do while task, we are looping in to get an update, and once the update is received from the user, it is like aggregated, it is converted into string, and it's appended with a username, all using JS and JQ transform task, and then the updates are posted to the required Slack channel. So we have a blog that is dedicated to this. You can go through that to view the executions, and we have a video guide too. So this is how it works. When the workflow starts, it is waiting for the update from the employee one. So what happens is the stand-up board which you've created in the Slack would ask the update to the employees, and once the employee provide an update, what happens? It posts them to the dedicated channel so that it would be completed. So once all the updates are completed, we can get the details of the stand up updates of all the team. And you can also schedule this using a scheduler so that this runs at every scheduled time within your organization.